and welcome to Engineering with Rosie Live. Sorry for the late start. Having some internet problems. Those of you joining me from Australia probably can relate. We, for some reason, never decided that good internet was something worth investing in. It was a big shock for me moving back from Europe to Australia, and going back about 200 years in terms of internet speed, it felt like. Anyway, I have a fantastic guest here today joining me, Michael Liebreich. So I'll introduce you properly in a second, Michael, but maybe you want to just say a quick hi now.
Well, hello. It's fantastic to be here, Rosie. It's really a pleasure. If you want me to give a couple of words on who I am, Michael Liebreich, I guess I do lots of things around the net zero transition, around information advisory, media, my own podcast, Cleaning Up, angel portfolio, loads and loads of things. We'll get into some of them, I've absolutely no doubt.
Yeah, awesome. So the way that I got to know you was through, I think actually probably like a lot of people, it was researching hydrogen and your hydrogen ladder. I am going to try really hard to stay mostly away from hydrogen today because I get sick of talking about it. So I can only imagine how sick of it you must get. And then also through your podcast, Cleaning Up, which is one of the really good ones on energy, and you get really great guests on. Anyone who doesn't know it, then check that out. I think I put the link in the description actually.
That's great. Yes, I mean hydrogen. The funny thing is, I play hydrogen bingo in meetings where the first person to use the word hydrogen has to sort of buy a drink from the pub afterwards, because once you mention the word, it kind of everything spirals, everything just goes down the hydrogen plug hole. So, but I'm happy to talk about anything, to be honest.
Yeah, I just don't want to only talk about it. I did. I asked my Patreon team ahead of time what they wanted to talk about, and there were a couple of people that had hydrogen-related questions. And I do feel that that's one of the perks of being on the team is that you get to ask questions ahead of time, and I do try really hard to get to most of those ones. Okay. Well, let's push on because we're late starting. So. We talked a little bit, it was a while ago now, but we did a pre-call and, got chatting a little bit. And we kept on talking about, we were talking about Greta Thunberg and how both of us felt a little funny about some things that she said. So, she keeps on saying that we haven't made any progress yet. And she had that speech with blah, blah, blah. I think we both said we felt a bit offended by that because I know that I don't feel like I haven't been doing anything over the past little while. I've been working in this space 15, 20 years. And I think other engineers working with energy transition technologies also haven't been doing nothing. And it's because of engineers that we actually do have clean technologies to facilitate the transition away from fossil fuels. I think that's another thing that Greta says that I disagree with. She thinks that, we don't have the technologies, and so there's going to be a lot of deprivation in the energy transition. And I think that that's a little bit wrong. So, Michael, since you've had such an interesting career in this space and over a long time, I thought it would be cool if we took, a trip back in time. And if I recall, when I was getting started in my career, fresh out of uni, I worked for a solar research company, was one of the earliest jobs that I had. It was like a kind of artificial photosynthesis technology. And I remember at my first annual performance review and salary review, I did some research into what market rate was and realized then what I should have realized a year earlier when I accepted the job, that I was underpaid by about 20-30%. And I raised it at the meeting, and my manager just laughed at me. He's like, "Yeah, you're working in renewables. That's what happens. You have to take a pay cut to work on something so niche." So I wanted to ask, what was it like for you when you got started a little bit earlier than that? Could you tell me, set the scene for what was it like when you first got started in renewable energy technologies?
Okay, so you've opened up a whole sort of, Pandora's box of issues there, but they all relate to kind of what has been happening over the last, let's call it 20 years, because I founded New Energy Finance, the information provider, 20 years ago, pretty much, the 2003, April 2004 officially, but I was researching it exactly 20 years ago. And So, that's the period that Greta Thunberg says, you grown-ups have done absolutely nothing. And, it's okay because I'm not grown-up, so I'm not offended. But I think that, and her role, by the way, I don't actually criticize her, because her role is to put maximum pressure on people like us. And that's fine. She does a great job of that. Perhaps, I would argue that she sort of hasn't got the current information on what's actually going on in the energy transition. So over the last 20 years, yes, when I started researching for new energy finance, there was no such thing as clean energy. There was no transition. Renewables were called alternative energy, which I found very offensive. And today, 75% of all of the capacity being added to the electrical system is renewables. So there's absolutely nothing alternative about it whatsoever. But back then, it was called alternative energy. And I would say that my friends, my peers, thought that I had completely thrown away my career by going into analyzing, tracking clean energy technologies. Now, what they maybe didn't realize is that my career had blown up because of the dot-com boom bust and technology cycle and whatever. So I actually felt like, well, I was sort of grasping at straws, but the straw that I decided to grasp, I didn't think was a straw. I thought it was like, I had the time to step back after that technology cycle, and I figured out, I guess, one of the earlier people to do so, that this was a mega trend. And just to put some numbers on it, in 2004, the first year for which New Energy Finance tracked investment flows in transition technologies, there was only renewables, and it was $32 billion that was invested globally in clean energy. Now, billions always sound big, but if you compare it to 1.2 trillion that was being invested at the time in non-clean energies, then that puts it in perspective. Well, last year, Bloomberg figures from my old team that I created, that figure had grown to $1.1 trillion, of which about $500 billion was renewables and about $500 billion was electric vehicles, and then there was about 100 billion of sort of other, which is a whole hydrogen and other things. So that change over that period has been absolutely chalk and cheese. This is now mainstream. You would no longer be taking a discount to go and work on clean energy. You'd be getting a premium if you had those skills. And just finally, in terms of going back to Greta Thunberg and emissions, there's this trope that emissions just keep soaring away, and they go up, and it's unstoppable. So now, concentrations in the atmosphere are continuing to increase, but the annual emissions, what actually comes out at the end of the pipe of the energy system, are almost flat and have been for about 10 or 12 years. So that incredible surge of emissions, and most recently because of China going hell for leather coal-fired export strategy, which was sort of 1995 to 2010, that soaring increase in emissions has actually been almost entirely capped by the efforts of people in this sector, among others. And so whether it's energy efficiency, whether it's renewables, structural changes in economies, so China moving more to services, Alibaba rather than just building more and more, railway lines, those sorts of things. But we have reached pretty much peak emissions, and I think we need to celebrate that. I don't like being told that's irrelevant, you've done nothing, it's all blah blah blah. I don't like that. Too many people that I know and love have worked too hard capping the annual emissions for me to just kind of, that's fine. Just be as angry as you want, that's fine.
Yeah, I don't think it's motivating to just say year after year that we've done nothing, continued to do nothing. And I think it's interesting what you say with the, emissions flattening, because I like to think of it like a cruise ship. It's going fast in one direction. By the time that it's slowed down, turned around, and going in the other direction, okay, it's stationary now. It's not moving, fast the direction you need to go. But all the hard work is in the turning around, not actually the acceleration. In a straight line is the easy part. And I feel like we're at that point now.
No, and there's no question. We need to get to net zero, right? So that's not. It's not to denigrate the what we need to do. And that line that was just racing off to infinity has now been stopped, but it needs to go back down the other side, and we have not gone back down the other side. And I don't think we are going to go fast enough back down the other side. But I don't think it's helpful to say we've achieved nothing. I think it's disempowering. Now, I mean, like I say, I don't criticize Greta Thunberg for what she does, because in a way what you need is the extreme voices, because then there can be some voices of reason, which I would like to think is you and me and a bunch of people saying, well, that's fine, that puts the pressure on. Where we are actually is we have these technologies, they have achieved an enormous amount. Society has got the Paris Agreement and in the UK the Climate Change Act, and there an enormous amount of work has been done, even in Australia. And I would argue that we need to kind of bank the win, but also keep the pressure on to move on.
Yeah, no, I mean, I definitely agree with that. And, looking back to my career, when I fast forward, 15 years on from that job, I definitely don't take a pay cut anymore. And the last big company I was working for, a wind turbine manufacturer, I actually had colleagues who were climate change deniers. They're definitely not taking a pay cut to, work on renewables. And, to them, it was just another job. And to me, I think that's been the biggest change that I've seen over my career, is that it's gone from something that you had to be passionate about and willing to sacrifice for, through to something where it's just, it's not only about money. There's plenty of people that are involved because they're passionate, but there are also people who are only involved for the money. And I've seen how fast things move when those kind of people get in on the act too.
I'm maybe, I don't know if it's because I'm more charitable. I think those who know me well would hardly argue that. But I don't like to call them deniers. I think deniers is a very dangerous word, because it's sort of an attempt to push them out of a discussion, make them feel uncomfortable, silence voices. Actually, in a sense, who cares? These are just people who are not seeing everything through the climate lens. They may, when you unpick it, they'll probably agree that it's getting warmer. They'll probably agree that humans have got some impact. What they may not agree with is the fact that we're, that there's impending doom and disaster on a short-term time frame, which, and I have some sympathy for that. The point is, they are working for companies that are part of the solution, or they are financing part of it. So who cares? And another way, I think, the situation we're in historically, another way of looking at that is that when I started, going back to that 20 years ago, the only reason to do clean energy or renewables was they were clean, right? It was just an environmental driver. But there's the famous energy trilemma, which is affordability, reliability, and sustainability. And so renewables won on sustainability, but back in 2004, 5, 6, 7, 8, 9, they did not win on economics or resilience. And then suddenly around 2012, you had this kind of, everybody woke up to the fact that actually the learning curves, all those engineers working away, all those financiers as well, by the way, had pushed the costs down, where suddenly it was like, oh my God, look at this. They are actually cheap. No, they may not be resilient, but at least they're cheap. If you need new electricity, you can get solar, you can get wind, bang it into the grid. If your grid has got some flexibility, boom, you're saving money. So that kind of ticked two boxes. You've got it's clean, and now it becomes affordable, but it wasn't resilient. And there was always kind of, well, what happens when the wind doesn't this and the sun doesn't that? And of course and what happened, if you look at the recent events, the Russian invasion of Ukraine, suddenly it's come home to people that actually fossil fuels are the ones that are not resilient. Fossil fuels are the ones, people try to say, the electricity price went up in the UK because of the wind power. And you're like, no, every single rotation of a wind turbine, offshore, onshore, every single kilowatt hour coming out of a solar panel reduced the amount of high cost gas we had to buy. And so suddenly that resilience argument is sort of, it's like the tumbrils of a lock, clean, click, affordable, click, resilient, click. And now we're seeing this enormous acceleration.
Yeah, definitely agree with that. And I kind of reject the framing of renewables as unreliable. They're variable, but if you look at the reliability metric that we use in the industry is uptime or availability or something like that, and they're perfectly they have good uptime, good availability. In general.
Uptime, I agree, but there's another one which also in the industry is how much of it can fall away unexpectedly tomorrow. And yes, tomorrow it might be a bit cloudier, and the weather forecast, by the way, tomorrow will be within 5%, 3% of output that's forecast. A week out it's a bit more, but if it's a gigawatt scale coal or gas or nuclear plant that goes down and you lose a gigawatt within a few seconds, that's actually much harder to deal with for the grid than this variability of renewables, which is almost entirely foreseeable.
Yeah, definitely. And if you look at, Australia had a price spike in our electricity prices last year too. And it was partly because of the international gas price. But the second biggest factor was that a lot of coal power plants were, their mines were flooded. And also there was one big sudden failure of a coal power plant a year or two ago that still isn't back online. That made up the vast bulk of the reason for the surge in prices. And so there's unreliability there as well.
Although, of course, what you get in the culture wars is even if it's a coal-fired power station that falls over, or their coal piles freeze in Texas, which happens every so often, or the nuclear goes offline because of jellyfish or hot rivers or whatever, it's always renewables' fault. The first news story is always like that car carrier that burnt off, I think it was on Holland or something. Immediately it's the electric cars. There were 50 electric cars. Boom, it must be the electric cars that caused it. And it's only later that you actually get the kind of, actually, in fact, wrong. It wasn't. It was the conventional energy stuff that caused the problem.
Yeah. And articles about that are still saying it was possibly caused by EVs. So, it's not even about going back and correcting as even, you can't get it right for the future. But, that's one thing. Okay, I've just realized I forgot to do all of the normal things that I do at the start because I was a bit flustered by the technical problem. So I do need to thank the sponsor of these live streams, which is WeatherGuard Lightning Tech, and they make Strike Tape, which is a retrofittable lightning protection system for things that go fast, like wind turbine blades and aircraft. And the other important thing I forgot to do was to welcome all the viewers and to invite them to please comment, let me know where you're watching from, what your interest is. And we're going to do a rapid fire round later on where I'm going to pose a series of technologies to Michael and ask him to very, very quickly give a judgment on those. So I have a very long list, actually, so you're going to have to be very fast with your responses. But anyone watching that has a technology that they want to see added to that, then please do so in the comments. Okay, let me just go to my outline and see. Yeah, okay. So one of the questions I wanted to ask you was, what are some of the favorite projects that you see happening now?
Okay, so it's a great question. I just have to I'll have to caveat because some of them are projects obviously that I'm involved in and I'm excited about. So I might be an advisor to one of the companies. But by the way, before anybody says, Michael's talking up his book, I tend to get involved in things that I like. So it's I like them before I invest, or I like them before I'm an advisor. So I've just come from, a few weeks ago, I was in southern Germany at a place called Geretsried, near to Munich. And that is where a company called Eavor, a Canadian company called Eavor, is drilling the first commercial closed-loop geothermal. Now, I know in Australia, you've got this thing called hot rocks or hot dry rocks, and you've been trying for decades and decades to you drill and then you frack and it just doesn't kind of work. Or it's been very expensive, or it's caused earthquakes. This is closed loop. So you drill down, 2 holes down, then you drill laterally, and then, clever bit, you link it up and you seal it. So it doesn't interfere with the water table. It doesn't have, you use your own water. Doesn't produce solids, it doesn't off-gas CO2, all the bad things about, frankly, first and second generation, how many generations of deep geothermal and fracked geothermal, ESG, this kind of resolves all of them. It's a lot of drilling and it's not cheap. But on the other hand, it's a mechanical process, a manufacturing type process and that's a really exciting project. It's going to be 300 or 400 million euros, and at the opening, they invited the Canadian Environment Minister, the Canadian Ambassador, the Bavarian Head of State, the Bavarian Energy Minister, the German Technology Minister, and the Chancellor of Germany, hoping that one of them would come and cut the ribbon. And they all turned up. It's that exciting. So that's what I'm really fired up about. I don't know. Do you want me to do some more?
Can I just?
Yeah.
Yeah. Is that Eavor? Is that
Eavor? Well, they pronounce it Eavor. 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 Yes. That's the one.
It's so funny because I literally just searched this like right before I came on, partly because one of my Patreons wanted me to ask you about geothermal and specifically reference this, but also because I noted that they actually have a commercial project already. They've already actually done something. You know, on my channel, I'm always trying to visit projects that are, you know, actually being done and not just computer renderings of what they hope that it will look like. So I had this noted down in my travel ideas for next time I'm in Europe.
Fantastic. Or in Canada, because what they've got in Canada, they did something called Everlight, which was their trial. It's actually producing heat, but the heat is being vented, you know, which is a bit sad, but it's only a trial. It's a very small pilot. But here's the nice thing about it. I mean, one of the nice things is you've got this sort of underground loop, like a radiator loop. And 4 years ago, 2019, they filled it with water and they pumped for 3 hours, right? And what happens then is that you've got cold water that's being pumped down and hot water coming up. And there's this thing called the thermosiphon effect. Because the hot water is lighter and the cold water is heavier, it starts to pump itself around, and it's been doing that for 4 years. So there's no parasitic pumping load, unlike, you know, these other. The ESG, fracked next generation geothermal, you would have to keep pumping and pumping because you're trying to force water through these tiny little cracks. Whereas with Eavor, it just it pumps itself around. The other thing it does is it load follows, because if you have Eavor and solar, then during the day you can switch the Eavor off and use the solar, and the heat is continuing to flow through the rock, which is a pretty good insulator, sadly, for this, but the heat continues to flow into the water, and you can then surge in the evening. You could then generate twice as much power. So on those kind of morning and evening, you could use or at night you use your Eavor, and during the day you use solar, and it plays really nicely together. And all you need is 150, 170, 200 degrees heat, which you've got absolutely everywhere. This is not a geothermal that only works in, you know, Indonesia, Japan, and Nevada and New Zealand. This is, you know, if the costs can come down, if the drilling can be done efficiently, you know, it's hot and hard rock. So they are at the limits of knowledge and capability. But if they can get the costs of that down the way that shale drilling came down, then I think this thing is just, you know, it's just really exciting.
Yeah. Okay. Well, maybe when next time in Europe, you can help me out with an introduction to somebody there if you're happily involved.
Yeah. Okay.
Yeah. I still have never done a video on geothermal. Let's give us another thing that you're excited about.
Okay. So well, I'm trying to do this without getting back to the dreaded hydrogen. I mean, I do have a very exciting. I mean, there's I think. You know, we'll probably talk about green ammonia or green fertilizer, and that's the stuff that's some of the stuff that I am excited about. Let me think. You know, earlier stage technologies, getting magnesium out of seawater. That's another one that I'm not really involved, but I like the idea. Magnesium is a very, very interesting structural metal. Absolutely filthy. All comes from China, but we can get it out of salts, probably salt deposits more than seawater. So I'm excited about that. I think we have to do floating offshore. If you look at you know, places like Japan and South Korea, they're going to have to do floating offshore, and you know, because the continental, they have to do wind, they have to do offshore wind, and the continental shelves are not big enough. So I think floating offshore is going to have to work. So I'm how can I put it? I'm hoping that's an exciting one. Yeah, I mean, there's an enormous amount going on that I think, you know, we're not, despite the fact that we've reached peak emissions. It's very clear that even the existing technologies. I mean, you know, if you look at, for instance, how much solar and wind is happening in the developing world, I mean, setting aside China and India, a couple of places, but most of the rest of the developing world has got very, very low penetration still. So even I'm still excited about wind. I'm still excited about solar. I'm excited about batteries, not so much the grid connected batteries, but electrification of vehicles. And I'm really excited that we start to get a critical mass of electric vehicles that really make sense now to use for to help the grid. I'm really excited. I've been excited since I was 19 about heat pumps. I think heat pumps are adorable. It's an adorable technology, right? Because you use a small amount of work and you get a lot of heat, and it's incredibly elegant. And
it feels like you're breaking the laws of thermodynamics. So it's like pretty rebellious for an engineer.
not to a thermo geek, it doesn't. To a thermo geek, it feels like sort of you've just reached, they're kind of black belt in thermo jujitsu. It's sort of there's nothing unusual about it, but it's just using them really well. And I think we're about to see dramatic shifts in electrification of heat. Of course, domestic, commercial space heating, but all the way through into industry. And again, what's really interesting is first we're going to push through and just electrify a lot of heat, and then we're going to have a whole big chunk of demand response capacity, because it's much, much, much cheaper to store hot water or hot bricks than it is to store electricity. And I don't think that's going to change. So if we have a lot of electric heat, then suddenly we can say, well, why don't we shift it an hour or two? Why don't we avoid the evening peak, the point where everybody, checks their email and opens the fridge and flushes the loo and the pumps all go. So let's just not do some heating during that hour or that 90 minutes. Enormously helpful for the grid engineers.
Okay, I agree, and it relates to a question we've got from viewer Glenn Ryan. He's actually been on the show before. He's a solar hybrid PVT photovoltaic thermal solution developer, struggled to engage Australian and overseas governments in meaningful discussion around addressing renewable heat targets. Why? Because I think heat is like half of the energy load, but we do talk about it very little compared to electricity, I think.
Yeah. Glenn, hi there. I'm sorry, I'm probably not going to give you good news, right? And the reason is that even with PVT, so that's photovoltaic and thermal, so you're capturing the heat, because obviously, if PV is, let's call it 22% efficient, 24% efficient, the rest of it is heat. And so why not capture that? The problem is that, first of all, it's a lot more complex, and you've got a lot more the installation, and we haven't got enough installers and enough heating engineers anyway. And now you want to have a second system on your roof and integrate and so on. So there's complexity. But also remember that if you do have photovoltaics and a heat pump, then you're not getting 22 or 24% efficiency. You may be getting 80 or 100% efficiency, because you're upgrading the heat. So why would you do the complex thing with two heat collection systems, energy collection systems, when you can just do a nice simple collect the electricity and then manage the heat in a sense separately and with high efficiency? And of course on cooling, although you can turn your PVT, the T, you can turn that into air conditioning, but you can do the same with the PV. So I just feel that the driver for PVT is simply not powerful enough to overcome the resistance, the friction, the complexity, and so I can't be optimistic. I think that maybe that explains a little bit of the resistance that you find, but I don't know. I can't be too optimistic on that one, I'm afraid.
I like. Have you seen those seasonal thermal storage in like Scandinavia and Canada? To me, that seems like that should be a big part of the the seasonal mismatch. People often talk about the need for seasonal storage because you've got this huge need for heating in the winter, and your solar power comes mostly from the summer. And I mean, they're really actually quite efficient, long duration systems that have been operating for ages. Do you see something like that? Yeah. You know what I'm talking about, right? Do you see it rolling out more?
There's a couple of different ways of doing that, a few different ways. So what you're doing is you're taking heat during the summer when you don't need it, and you're bunging it either underground. So in Canada, I can't remember
I might be able to find it.
It's got something called begins with OK. Something or other. Anyway, near to Alberta, in Alberta, near to Calgary, I went to see a system, and they're putting it underground using geothermal. I think sort of 12 by 12, an array of 144 geothermal boards, putting it underground, heating up a big square of earth underground. You can also put it into hot water, but you need a lot of hot water. You can put it into phase change materials and so on. I do like it. I like the ones that are simplest. So just heat up a block of earth rather than the ones that get very engineering and technical and difficult, because then you've got maintenance and lifetime issues and so on. I do like it. But again, it doesn't mean that you would necessarily use thermal, because remember, if you've got PV, you could still upgrade, even if you want to store it at 100 degrees or whatever, 150 degrees, you could still use a heat pump to upgrade using the PV. The clever bit is always, I'm afraid, the work, not the heat. So if you have an opportunity to get work rather than heat, then you should do that, right? Because work is, I don't know what the number will be, 2, 3, 4, 5 times as valuable as heat. So I know that, Rosie, I'm really sorry, because there are going to be loads of people who do solar thermal who will be like, that guy's an idiot. Why did you have him on the show? And you'll I'm sorry. I'm not a huge fan. I am a fan of PV, of solar thermal, but kind of when you can't do PV, so it's going to be more niche.
Okay, no, that's fair, and Glenn's used to it. This the last time that I asked about solar thermal from a guest, they also weren't a fan. But I'm a fan of a lot of different kinds of solar thermal, and definitely when you need heat, it's a lot easier to create and store heat than electricity. So I think that people maybe don't appreciate that so much.
And remember that the world is not uniform. So if you look at, I'm not a huge expert on household habits and so on in the developing world. But if you just want a hot shower at the end of the day, then there's nothing simpler than just doing some solar thermal on the roof. And so there'll be all sorts of places where you do use solar thermal.
Yeah. Okay. All right. So we're running out of time. I want to leave a good chunk of time for this rapid fire round, but then after that, I want to ask you about the future. So we need to save some time, and that means I'm never disciplined on these, and we always just end up, the rapid fire round is just as slow as the rest of it. So we need to be disciplined, and just your just instinctive, just 2 or 3 word response that comes to mind for these certain technologies. Okay. Can you commit to that?
I'll do my best. I'm not good at being precise.
All right. So first of all, in wind energy, my first renewable energy love, airborne wind.
Horrible.
So
forget it.
Kites. I know there's one viewer who's written it kind of good about
far too fragile. No.
Floating offshore, you already mentioned. You're a fan?
I'm a fan by necessity. It's not going to be cheap. Maybe it might. If we're really lucky, we'll get it cheaper than fixed base offshore, and maybe not bring the electricity back to shore. Maybe do things with it, or the power, or whatever. But so kind of big future. Yes.
Equinor's already doing it for such fancy offshore activities as oil and gas. Okay, so small wind, distributed wind. We've got rooftop solar, rooftop wind.
Don't like it. Too complicated. Maintenance, very niche. Makes some people happy, but it's not going to move the dial on climate or large scale use.
Yeah. Okay. All right. Let's go to hydrogen now. Home heating. Hydrogen for home heating.
Forget it. All sorts. Sorry, say again.
I was just going to move on to the next topic.
Hydrogen. Horrible use of hydrogen.
Power system balancing. So you use variable renewables in a variable way. Yeah.
Yeah. So this is a hydrogen question for power system balancing.
Yeah.
So long duration storage, 48 hours a week plus, all the way up to seasonal and maybe even inter-year, which is also a thing that we're going to need to think about. Yes, right? But when you look at balancing, the marginal cost of using a battery is zero. The marginal cost of using hydrogen is never going to be zero. So it's always going to be outcompeted. It's a stupid thing to do. We shouldn't do it.
Shipping.
So I think my favorite technology for, well, first of all, inland shipping, short distance shipping, all going electric, right? That's the first thing to say. The second thing is long distance shipping. My favorite technology right now, frankly, is biogas or biomethane. I can't understand why it isn't the thing everybody's talking about, because all the biogas we produce, we do stupid things like put it into the grid to use it for power generation and heating, where we have better solutions. And right now, you could buy a ship that uses CNG and run it on bio-CNG and done. Now, will there be enough bio? I think there'll be more than we think, but we may need to use some form of synthetic fuel, an ammonia, a methanol. I think I'm tending methanol, but I don't want to come down firmly on that side. E-fuels for shipping, no, much too expensive, no point. Maybe for aviation.
Hydrogen for shipping?
Hydrogen
is that on your list?
No, we're not going to move. We're not going to move a sausage of hydrogen as liquid hydrogen long distance. All this stuff about Australia, making, by the way, grey hydrogen and then shipping it off to Japan, and it's a vast triumph that some of it arrived at the other end. The hydrogen. So take one.
It's not even grey, by the way. It's brown. It's brown coal. The gas.
Well, I was being polite.
Yeah. You're giving us too much credit. And it wasn't much.
The simple calculation on shipping of hydrogen as liquid hydrogen is, if you take one LNG carrier, one of those big QMax LNG carriers, and you say, let's get that amount of energy to Japan or Germany or Korea, wherever it's going, as liquid hydrogen. The first thing, you need to start with essentially 5 LNG carriers of volume of liquid hydrogen, because it's so non-dense, 71 kilos per cubic meter, right? And the first 2 ships worth you use to liquefy 3 more. And then those 3 more are what actually carries the energy of one LNG carrier. But the problem is, as soon as you've done that, it starts boiling off, and you lose about 20% of it, en route. I mean, it's just a complete no. So there'll be none of that.
Okay, cool. Yeah, all right. That's all on hydrogen. Let's move on to energy storage.
I should say, we might ship ammonia, right? Because ammonia is much easier to ship, but then we're not going to turn it back into electricity. That would be absolute insanity. We'll just use it as fertilizer and and whatever other uses you've got for ammonia. We might use a little bit for power storage.
Do you think that ships will run on ammonia?
So, like I said, I'm tending methanol, not because it's necessarily cheaper, but because it's just so, operationally, it's so much more straightforward. And that's the decision that Maersk made when they decided the only way that they could see net zero shipping at blah, 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 was going to be methanol. Others have made a different decision and are going with ammonia. I think it's really complex. Really, to see, I don't know how many ports there are in the world that would need to be bunkering ammonia and moving it around. And it's just a horrible, horrible thing to be handling. You can do it, we do it, but it is essentially always complex to handle and unsafe. And I wouldn't want to have my kids crewing an ammonia fueled ship.
Yeah, it doesn't combine well with water, right? Okay, energy storage then. Gravity energy storage.
Absolutely horrible. Forget it. The amount of energy that's stored, gravitationally, it's the mass times the times the height times g, and you can calculate it. If you're bored one day, and if you have got an engineering sort of tendency, which I suspect many of your audience do a calculation of the chemical energy in a kilo of fuel, any fuel, doesn't matter which, versus the gravitational energy in a kilo weight. And so for hydrogen, if you took a kilo of hydrogen, you would have to lift it, I think it's 35,000 kilometers in the air to give it the same energy as its chemical energy. And of course, by that time, it's in orbit. And if you think about it, it's obvious, because hydrogen is rocket fuel. It's just that the piddling I'm sorry to you. I don't know if you can blank that out if it's a bad word, but the piddling amount of energy
Is that a bad
that
word?
you get from gravitational storage for these vast constructions of lifting weights and pulleys and cables that all have to be maintained. It's a joke. It's nothing other than a joke.
Yeah. Okay. Pumped hydro, gravity, technically, but
Pumped hydro is different because what you're doing there is because of the area, you've actually got a relatively small height difference. You've got a big volume because of the area of a reservoir, and of course you don't have all those pulleys and what. So pumped hydro, of course, yes. Now there is one of your professors who's saying, "Oh, you can do much more pumped hydro." He went on Google Maps and he found reservoirs up and down and whatever. And
he did a little bit more than go on Google Maps.
Do you know what? Yeah, he didn't. No, he didn't, because when you look at Europe, the industrial areas of Europe do not have mountains, right? Northern Germany, Holland, the UK, they're not near to the reservoirs. And I mean, how can I put it? I spent a lot of time in Switzerland. The idea that you're going to build lots of new reservoirs and drill. They've just done one in Switzerland, and it cost something like 1 billion Swiss francs or 2 billion, so huge amounts for interesting amounts of storage, but on the scale of what the country needs, it's maybe a couple of minutes of power storage. So I think that I don't want to say anything too negative about somebody's favorite PhD postdoc's work and whatever, but I'm absolutely not saying. See there, look, you can see it on the video. There is none in Northern Europe or Southern UK, right? It's all in the Alps, and then it's basically in places where it's very, very difficult to build new infrastructure for physical reasons, also for regulatory reasons, for NIMBY reasons, and then it's in the wrong place. It's not in Germany, Belgium, Northern France, the UK. It's not in the industrial areas, not in Poland. So you've got to somehow. I think thinking that there will be an order of magnitude increase in pumped storage in Europe is fantasy thinking, I'm afraid.
And our big shiny pumped hydro project in Australia, Snowy Hydro 2.0, has just announced a cost increase of sixfold, and it's blown out to 2030 now. So I'm sure that
because these are all mega. If they're big enough to be useful, then they are mega projects, and as soon as they're mega projects, then boom, you get into mega project delay land, unfortunately, which we see with nuclear, we see with these huge projects.
And if people want to know more about that, they have to listen to your episode on that. How what was the author's name?
Ben Flubier. How big things get done. The professor in Denmark who's got this huge database and shows how delayed they get. And basically, the bigger it is, the more delayed it gets. That's the sort of short. Or the less modular it is, the more delayed it gets.
Okay, flow batteries.
I love them. Again, there's another sort of adorable technology, right? Because it's so elegant. For some reason, though, they've never really taken off. I think a lot of it is around, they leak or they use sort of toxic chemicals, and then there's always somebody who's but we can do it with a non-toxic chemical, but then it's less efficient, or less this, or less that. So for some reason, we've not seen, what I've called in other places the sneeze, where it kind of bimbles along for a while, and then suddenly, achoo, and off it goes, off to the races. We just haven't seen that. I'd love to see
announcements recently. I wonder if we're about there. I'm not sure, but I like them too.
Rose, the problem is I've seen 20 years of announcements, 20 years of it going to be the next big thing. And at some point, one of two things happens. Either at some point it is the next big thing, or it never is. And I'm on the fence. I don't know. I wish them luck. I wish anybody their luck. I mean, maybe Glenn, if he does give up doing PVT, maybe he could do flow batteries and hit it big time.
He's got plenty going on. Ocean energy. This came from Patreon in 3 forms: wave energy, tidal currents, and ocean currents. What's your one-word assessment of each of those?
Wave energy, forget. Far too much kit, far too heavy, far too much steel, far too much cement, and it's one of those. It's a predatory delay technology, because it gets a lot of support and love from people who say, "Oh, don't do onshore wind. Onshore wind's ugly. Do wave." But of course, as soon as you try to do wave, they would say, but that's my favorite beach. You can't do it there, and you can't do it there. And in fact, you can't do it anywhere. So wave is never going to happen. And maybe some niches where you might use it for a marina or in the Navy or whatever, or an tiny island. I can't even imagine, but could be. But basically, no. I think tidal currents, the tidal barrages, yes, but it's going to be where you can retrofit it to some existing infrastructure, an existing port infrastructure, an existing flood protection infrastructure, because it's just too much concrete that you have to move around to create the structure, to create the potential energy. And then I think the tidal flows, ocean current, I don't know how you harvest from an ocean current, but tidal
I don't know either. That was a new one for me.
Yes, I like it. It's expensive, but it's very, very dependable. And so I kind of like it, but I don't like it hugely. And the other one you're missing is OTEC, which I kind of like. And OTEC is ocean thermal, where you've got a thermal gradient. And there are places where, it's one of those things that's kind of, it's a long-term, very expensive project, but it will work for decades and decades and decades. You've got cold water down deep, you've got hot water on the surface, and from that temperature difference, and you can integrate it with, what's fish culture? You can integrate it with some food industries and so on. And there are places in the world where it will be fantastic, but they'll be quite limited.
Yeah. Okay. And finally, nuclear.
So nuclear, I divide into probably 4. Keep what you've got. Number 1, if it's working and it's safe and it's big and it's clean, keep it. Pretty obvious, but that seems to have passed the Germans by. Shutting down big, good plants early is basically a crime against the climate and a crime against people with respiratory disease, because it tends to go back to coal, at least temporarily. If you look at building gigawatts, then you've got the Bent Fluvier, how big things get done problem. They run enormously late, enormously over cost. We've seen it time and time again. By the way, they also are heavily subsidized in the countries that people hold up as examples, China, India, etc. There the costs are just socialized and hidden in all sorts of budgets. So the gigawatt scale stuff has basically been tested to economic destruction. Small modular reactors, they will start with a cost disadvantage, right? We've got to be honest about this. Because they're small, they'll cost more than gigawatt scale. The hope is that they'll come down the cost curve if we build enough of them, but they will be expensive. I think they will have a role as long as the energy system and the regulation matches them to demand response. So what you want to do is to use them to power desalination or electrolysis or some process, some industrial process that you can switch off. So then when there's no wind and no sun, you can switch off the electrolysis or the desalination or whatever and use the electricity, feed it into the grid to keep the lights on and the ambulances charged. And so I see a role, but the scale of it is going to be small compared to the climate challenge. So I just back of envelope, if you take a 100 megawatt small modular reactor, so something like the new scale reactor that's the furthest advanced in the licensing process. By the way, we might have 1 or 2 by 2030. 100 megawatt reactor, and you do the maths, which I'm sure I know you and many of your audience could do, and you work out how many gigawatt hours that would produce during a year based on 90% uptime, and then have a look at how many of those it would require for SMRs, small modular reactors, to overtake the contribution of wind and solar today. And the answer is about 5,400 of them. And we're going to get maybe 1 or 2 by 2030, maybe 50 or 100 by 2040. I can't imagine we're going to get 5,400. And even then, what they're delivering...
That would be a big sneeze.
It would be a big sneeze. And even then, it's 15% of electricity, which is only 20% of global energy demand. So even then, it's only 4% of the problem that you've solved, even if you can build 5,400 of them. So it's kind of like, yes, but, and then the fourth one is fusion. where, I love it and I think we should spend money on trying it, but I think we'll be lucky to get the first one feeding the grid by 2030. Then it has to be turned into a commercial, replicatable design where we know what to do with the radioactive reaction chamber linings when we strip them out and all sorts of things. If we get a replicatable design and build 5 or 10 by 2040, it's trivial compared to the climate challenge. And maybe by 2050, 1% of our electricity, 1%, not even 15, will be fusion. That's the reality. It's a 3-decade thing, lab experiments, commercial design, and start to roll it out, and then build it to 1% by 2050. And both SMRs and fusion, we need to push ahead because the second half of the century, we're going to need a lot of clean energy. So it's not like suddenly we can stop in 2050. Oh, jolly good, we're there. No, we're going to need a lot. So I think that we need to, get them mature by 2040 in the case of SMRs and 50 in the case of fusion, mature and replicatable and being churned out. That's a good thing to do. But let's not kid ourselves that it's going to help us hit some 2050 target. It's really not.
Yeah, I like fusion too, but for the next energy transition, not this one. Yeah. Okay, so let's see how I asked you did a YouTube poll on which energy tech do they think is most underutilized today, and most YouTubers do not agree with you. They think that nuclear is the future, and last place was a combo of airborne wind and hydrogen. Interesting that they're coming in together. I personally quite like airborne, but in that, you're involved in venture capital, right? So you don't expect every company that you invest in to succeed. You would invest if you saw, what would be the chance, the odds that you would accept? 1 in 30, 1 in 10? What is your
I like
your
to
goal?
bend the odds. I mean, I've got my model is to do the analysis, find sectors or technologies that I like, find the best team, the best technologies, and I've just become an advisor to Hysata, Australian company, hydrogen electrolyzers. They look like being 15% more efficient, so 95% efficiency against the higher heat value of hydrogen. And I'm all in as an advisor, and at their next round, if they let me, I might invest. So that's kind of my modus operandi. I don't want to have 29 failures out of 30. I like having 0 failures. Failures hurt. I think that the problem with airborne wind is they will have 100% failures. Basically, the higher it goes, the better the wind, and the higher it goes, the heavier your cable, and the harder it is to get the electricity back, or to get the energy and the power back to Earth, whether it's generated up there or whether it's just it's just not going to happen, folks. It's something that you'll always get some rich fool that you can get some money from because it ought to work and it sounds great and so on. I just don't think it ever will. And I'm sorry not to be positive, and I'm probably unpersuadable on that one. What can I say?
Yeah, well, I think that there's some sort of maybe like around 1 in 30 chance that someone will make it work with airborne wind. And I like the fact that they've got that kind of disruptive technology path where there is currently a niche that they can fill better than anyone else, a small one.
Then that's a question about what's the market size. Can somebody get it to work, right? It's a bit like,
they already have,
the hydrogen car. I mean, it's a lovely car. You could drive around, right? But that doesn't make it. I'm only interested in things that can scale and solve big chunks of the challenge. I'm not interested in a niche thing that says, well, I can postulate, this kind of extreme edge case where you're in Nepal in a situation like this, and there's the road, and there's been this storm, and then how are you going to do it? I don't care how we do the last 5% or the last 10% or some little niches. I care about the big chunks.
Yeah. No, that's fair enough. And we've got a good comment to wrap up this section. Andrew Radford says, I like how Michael calls a spade. And I think that no one could deny that about you.
I'm waiting for Rosie, I'm waiting for him to say, but.
No, I think he's a fan. Well, I'm reading that in. He can comment what he thinks. So we have run out of time, but I do just want to go slightly over to ask you, what do you think that we should be working, or what's the main thing that we should be doing differently to what we're doing now for the future? What's the most important thing that we're not doing, that we're getting wrong?
So I think there's 4 or 5 big things that we need to do. So we need massively to up our game on transmission, right? Because everything that I do, there's energy efficiency, all of the paths make it clear that it's very difficult to suddenly do a handbrake turn and switch to absolutely colossal amounts of clean energy in the places where you need them. So the first thing will be energy efficiency. It's just profligate, the stuff we do. It's just ridiculous. So energy efficiency, and I would put in there things like electrification of transportation and electrification of heat, because both of them also reduce the amount of energy that we need at the front end of the system. Right? They're both much more efficient ways of doing what we do. But then transmission. The energy is going to be largely renewable because that's the cheapest, which means it's going to be in new places, offshore and in rural areas. It's also going to be variable, which means that you need to be planning, you're planning for the peak, and our transmission needs to plan for the peak. And we are just not remotely, nowhere in the world that I go are the policymakers, or frankly, the investors, of anybody focused enough on transmission. And when it takes 15 years to build a new transmission line, we've got to compress that to 5, whatever that takes. We've got to figure that out. Also, cost of capital in the developing world, because it's all very well saying, well, we're doing this in Australia, it's going to be marvelous. We're going to be fully clean electricity by 2035, and we're going to do this in Europe and the US and Japan. So, yeah, but most people don't live in those places. And Africa, with I think it's 20% of global population, is getting 2% of energy investment, and it's going to be 1 billion people, and they're smart and they're fast and they're growing, and we absolutely have to figure out. And the biggest thing is the cost of capital that's stopping them from benefiting from these technologies. And then I would say the final thing I would put on there is regulatory capture. We have got to stop messing around. In the UK at the moment, there's this big fight about hydrogen heating, and it's being driven by gas heating people who make lots of money putting boilers on walls, and the gas industry, the gas distribution industry, which has got reticulated gas pipelines in the road. And that is a stranded asset. It is going away. It does not have a role in a net zero 2050 future, but they are fighting incredibly hard and incredibly dirty, misinforming people. And we just got to somehow stop that. And in the US, you've got all these senators and these all these politicians that are bought and paid for by fossil fuel providers or industry, and it's just slowing everything down. And of course, in the developing world, in many parts of the world, you've got corruption, just straight out, paying money and bending things. And all of that is, if you gave me, in fact, of all of the above, the single thing, if it was if it was Christmas, I get one wish, I would say fix corruption and regulatory capture. Right? Fix campaign finance in the US. Fix that, because everything else is just sort of physics, engineering, microeconomics. We'll figure it out, and we can move a lot faster if we do that.
Yeah, I wish we had more time. I'd love to talk to you about stranded assets some more. My plan for the gas pipelines is, I read somewhere that there's like 4 years worth of steel in US gas pipelines. So that's my plan for it. It's a get rid of gas and, decarbonize steel at the same time plan for the pipelines. Okay. I better wrap up because we're over time. So much more good suggestions that I didn't get to. So sorry, everyone. Maybe you'll come back on one day and we can keep on talking.
I'd be delighted to. Thank you. It's been a lot of fun.
Oh, great. So need to thank sponsors, including the Patreon team, who you're probably the main sponsor of Engineering with Rosie. If you want to join us, then the link's in the description. I really love the community that we have, and I get great input ahead of discussions like this and future videos. Also thanks again to Weather Guard Lighting Tech. They also have a great tech newsletter and a podcast, which I co-host with Alan Hall and Joel Saxum each week. The links to that in the description. We talk about all kinds of clean energy tech news. A lot recently about, there's this big crisis in a lot of wind turbine manufacturers recently. So we talk about that in the most recent one too. Future videos, I released one just yesterday on aluminium actually, which is going quite well, and then the next one's going to be on bioenergy with carbon capture, which I probably should have asked your opinion on that because it tends to elicit passionate preferences one way or the other. But yeah, we'll have to save that for another day. And then, of course, biggest thanks to everybody watching and to Michael for joining us. It's been really, really great and, really fun conversation.
Well, thank you very much for having me. It has been fun. And I hope your audience, your listeners enjoy it.
Yeah, I think there's lots of good comments. So I think it's safe to say that they did.
Very
okay,
good.
well, I'll end it now. So thanks and see you in the next one.